In today's lecture, we will go over quantitative definitions of the work and the heat that are directly applicable in the chemical sciences. This lecture is therefore very important since it provides the basic information for many of the calculations you will have to carry out in various homework assignments and for your 3 tests this semester. We start with the expression of the work associated with the gravitational force, something you are familiar with and have studied in physics before, which we also reviewed in the fundamentals chapter. Then we develop an equation for the expansion-compression work of any substance under a constant external pressure. We emphasize the importance of SI units and revisit the sign convention discussed in last lecture. In subsequent slides, focusing on ideal gas systems, we showed that the expansion-compression work can be determined from a graphical representation of the external pressure as a function of the system's volume, and we consider the cases where the external pressure changes or remains constant during the change in volume. We examine how the work changes when we increase the number of steps or stages over which the volume of a gas is changed by a fixed amount. And we show that in the limit of a very large number of infinitesimal steps, the process of expansion or compression is reversible. That is, the magnitudes of the work of compression and expansion are identical for a given change in volume. We then recall some of the conclusions reached for ideal gases in the previous chapter and comment on the heat associated with the isothermal expansion or compression. We also discuss the heat associated with isothermal and isobaric chemical reactions and recall the concept of heat capacity, which you were introduced to in general chemistry. We conclude this lesson with a discussion of the molecular origin of the heat capacity.